All right, let's unpack this. For ages, large language models, well, they've been superstars in very specific areas like mathematics and coding.
Right, excelling where things are structured.
Exactly. Structured problems, clear-cut answers. But getting them to apply that same kind of reasoning to the messy, intricate challenges of the real world with all its diverse disciplines, that's been a really tough nut to crack. It's almost like having, a brilliant mathematician who kind of struggles with common sense sometimes.
Yeah, that's a good analogy.
So what's been holding them back? And crucially, how does this new work, this general reasoner, start to tackle it head on?
Well, what's truly fascinating here, I think, is how the authors really precisely identify the two main bottlenecks stopping LLMs from achieving true general reasoning.
Okay, what are they?
So first, there's just a scarcity of high-quality verifiable reasoning data once you step outside those neat mathematical or coding domains.
Right, not enough good examples.
Exactly. And second, there's the inherent inflexibility of the traditional, rule-based ways of checking answers.
Ah, okay.
If we think about the bigger picture, overcoming these limitations is absolutely fundamental. It's key for realizing truly general AI reasoning across all domains, moving beyond just specialized intelligence.
Exactly. So how did they actually bridge this gap? You said two main things.
Yes, two really ingenious innovations within their new paradigm, general reasoner.
Okay.
First off, let's talk about their new dataset. It's called WebInstruct-verified.
WebInstruct-verified. Got it.
And this is where the ingenuity really shines. They didn't just, scrape random web data. No, they meticulously curated something like 230,000 high-quality reasoning questions.
Wow, okay, where from?
Sources like Stack Exchange, places like that. And then they rigorously filtered them using advanced LLMs. They mentioned Gemini 1.5 Pro and Gemini 2.0 Flash.
Okay, what was the goal of the filtering?
The goal was to make sure they ended up with questions that had explicit, verifiable short answers.
Ah, verifiability is key.
Absolutely. And crucially, they even went so far as to exclude questions where maybe all the candidate solutions were just too simple, or maybe all of them failed. They wanted robust complexity.
It makes sense. Avoid the trivial stuff.
Right. And ensure a balanced domain distribution. So covering fields like physics, chemistry, finance, and various humanities too.
Okay, so a really diverse, high-quality, verifiable data set. That's innovation number one.
Correct. But this immediately raises a pretty important question for anyone building these systems.
Which is?
Once you have this incredibly diverse data, how do you reliably check answers that aren't just, simple numbers or exact string matches?
Right, the verification problem outside of math.
Exactly. That's where their second key contribution comes in, the general verifier.
Okay, the general verifier, how does that work?
Well, think about traditional rule-based methods. They're quite brittle, aren't they?
Yeah, very rigid.
Imagine trying to grade an essay with, like, a checklist designed for math problems. It just doesn't work for things like semantic equivalence or slightly different phrasing, which you get all the time outside strict math.
Totally.
So General Reasoner introduces this compact 1.5 billion parameter generative model-based verifier.
A model to check the answer.
Precisely. And it's specifically trained for chain of thought, context-aware verification.
Chain of thought, meaning it follows the reasoning steps?
Yes, it's trained to sort of think through the steps and the logical connections within an answer. This allows it to assess if a student model's answer is truly equivalent to the ground truth, even if the representation, the wording, is different.
That sounds much more flexible.
It is, and this capability provides robust, reliable reward signals for the reinforcement learning process. It essentially tells the main model when it's on the right track and guides its learning much more effectively. It's a significant leap forward, really, in scaling this kind of training.
Okay, so better data, better verification. What does this actually mean for performance? How well does it work?
Well, the paper demonstrates some pretty impressive results. They train General Reasoner in what they call a zero reinforcement learning setting.
Zero RL, what's that?
It means they do direct RL training on the base LLMs. Specifically, they use the Qwen 2.5 and Qwen 3 series models without doing any initial supervised fine-tuning.
Ah, straight to RL. Interesting. Is that efficient?
Remarkably so, based on their results. For example, their General Reasoner 4B model, it completes an MMLU-Pro computer science evaluation.
Which is a tough benchmark, right? Multidiscipline.
Yes, focused here on computer science problems within it. Anyway, it completes it in just 1.5 minutes with 61% accuracy.
A minute and a half, that's fast.
It is. Compare that to another method they mentioned, DeepScaleR 1.5b preview. That takes 18 minutes. 18 minutes for a lower accuracy, 35%, and produces these hugely long outputs, around 32,000 tokens.
Wow, compared to General Reasoner.
The General Reasoner's output was about 1,000 tokens.
Okay, that efficiency is really striking. It almost makes you wonder if we've been overcomplicating things sometimes.
It does raise that question.
Wow.
And looking at the broader picture, the evaluation picture, Their comprehensive assessment across 12 challenging benchmarks is really telling.
Which ones?
Things like MMLU-Pro, GPQA, SuperGPQA, these are all designed to really push the boundaries of AI knowledge and reasoning across a huge spectrum, plus a suite of diverse math tasks as well.
And the results?
General Reasoner consistently outperforms the existing baselines, like SimpleRL and Nematron Crossthink, especially on the general reasoning benchmarks. We're seeing roughly a 10% boost in areas like MMLU-Pro and SuperGPQA.
A solid improvement.
Very solid. And what's particularly compelling, I think, is that their best model, the General Reasoner QW314B, it can actually match or even surpass big commercial models like GPT-4o on some benchmarks.
Surpass GPT-4o. On which ones?
Benchmarks like GPQA and Theorem QA, which is truly remarkable, especially when you remember it relies solely on that zero-RL approach.
Yeah.
No supervised pre-training step.
That is remarkable. And did they do studies to figure out why it works so well? Like, break down the contributions.
Yes, the ablation studies are really useful here. They really underscore the impact of their two main innovations.
Okay, like the dataset.
Exactly. So the data abundance study, it shows that training on the full, diverse dataset doesn't just improve general reasoning across different fields. It actually maintains or even improves mathematical reasoning performance compared to models trained only on math data.
So it's not a trade-off. You don't lose math skills by adding physics or finance.
Apparently not. For their 14 billion parameter model, for example, it clearly benefits across every single metric when trained with diverse data. It seems to be a synergistic gain, enhancing overall capability.
That feels like a really key point. We're not just improving specific skills in isolation, but maybe building models that are fundamentally, well, smarter across the board. It challenges that old idea that breadth has to come at the expense of depth.
I agree. That's a potentially significant shift. And the general verifier, the other innovation, also really proves its worth.
How so?
They compared training using their model-based verifier versus a traditional rule-based one, using the Qwen3-4B base model.
Okay.
The model-based approach consistently yielded higher accuracy across all the benchmarks. And importantly, it showed continuous improvement throughout the training process.
Whereas the rule-based one?
The rule-based approach kind of plateaued early on. It limited further gains.
Ah.
And here's a critical detail: the agreement rate. They checked against a powerful model, Gemini 2.0 Flash. On a sample where Gemini said the answers were correct, their model-based verifier achieved almost 79% agreement.
Okay, 78.7%? Pretty high.
Right. Compare that to the rule-based verifier, just 22.2% agreement.
Wow, that's a huge difference.
It really is. And this is especially impactful for those unstructured answer types we talked about, lists, strings, and non-math STEM fields like physics and engineering, where the answer formats are just much more diverse and less predictable for rigid rules.
So the verifier isn't just theoretically better, it's practically enabling the model to actually learn from a much wider range of real-world problem-solving scenarios.
That's exactly it.
Okay, so wrapping this up, what does this all mean for the horizon of LLM capabilities? And, for those of us actually trying to leverage them in expert domains.
Well, this deep dive really reveals, I think, a compelling path forward.
Which is?
By meticulously curating diverse, verifiable data, and by innovating on how we assess complex answers, we're genuinely building LLMs that can reason across disciplines.
Yeah.
Not just in narrow silos.
Yeah. And the ability of General Reasoner to hit state-of-the-art performance with this zero-RL approach, even outperforming sophisticated commercial models in some areas, that raises a really important question for you, the listener. How will this paradigm shift in reasoning capability impact your specific application areas, especially maybe those demanding multidisciplinary insight?
It's worth considering the implications, right? Having LLMs that aren't just experts in a specific niche, but are becoming truly general reasoners, adaptable to the really intricate, complex challenges of the real world.
Definitely something to think about. A move from specialized tools towards more adaptable, general problem solvers.